Hello, this is G.Om Kedareshwar Kiran from 5th SEM Electrical Department. So, today I am presenting about semiconductor memory roadmap and advance in semiconductor memory. What are the advanced technologies in semiconductor memories and what is a semiconductor memory? So, in general, the semiconductor memory roadmap advanced semiconductor memory both are equal, but the semiconductor memory marketing is undergoing rapid transformation driven by unpredicted demand from artificial intelligence and data centers. The presentation outlines the key advantages and future directions in the semiconductor memory technologies, highlighting the innovations uh, propelling the industry towards projected record growth. Semiconductor memory market overview 2025 present. So the DRAM and NAND emerging memory, these all come under this. We can see the split pie chart over right side. The global semiconductor marketing is project to reach $697 billion by 2025, marking a period of record growth. The memory segment crucial components expansion of anti-predicted generated to $200 billion in a revenue of 2025, representing the impress 18% over an year increasing. So this growth is preliminarily fueled by the demands of AI, artificial intelligence, and large-scale data centers. Continuous innovation increased capacity in memory technologies. It leads about the marketing scale growth and potential, while DRAM, dynamic random access memory, AI chips, and particularly demand of high bandwidth memory (HBM). So now the DRAM technology, advanced DRAM technology, mainstream adaptation. Uh, the list of DRAMs are given here: DDR5 and LDDDR5 and 5X. These becoming mainstream in 2024 and 2025, providing faster data transfer rates, improved power efficiency in various platforms with power efficiency computing platforms, advanced lithography, wide spread adaptation of extreme ultraviolet and high K metal gate technology. These circuit patterns are advanced transistor performance. Smaller nodes, leading manufacturers like Samsung and SK Hynix are translating the 12 nm class DRAM cells, significant increasing memory density and efficiency. The next gen development is about 26 to 27, pushing the boundaries memory of performance and capacity even further. What is the capacity, maximum capacity to reach the DRAM technologies? And next one, high bandwidth memory HBM evaluation. How does it evaluated? Let us know. HBM revenue projected to double $17 billion in 2024 to $34 billion in 2025, underscoring the critical role of modern computing. It is a independency of AI infrastructure and large-scale model training, enabling rapid data access and complex computations through high-gen mass computing. And 12HI HBM Snappling HBM4, demonstrating continuous innovation and packing of skills technology. Samsung is validating the high bandwidth memory technology with plans mass production and the solidification of Poison high performance position and high performance memory segment. So next one, emerging 3D RAM advanced architectures. The 3D RAM means three-dimensional three-dimensional RAM. Shift to 3D RAM. The industry of moving towards 3D RAM architecture by 2033 to 34, departing from traditional planners designed to achieve greater density. Vertical transistors innovation include 4F square DRAM and featuring vertical transistor VTs and reduce the cell size, enhance the performance. And blonding the CMOS, blonding the CAB technology, advancing the water bonding, wafer bonding, or layer memory integration, density and reliability. These advancements are expected yield by 30% bit density improvement and significant enhance reliability and future memory devices. So SRAM, static random access memory, SRAM, scaling the 3D integration. Integration is generally the particular of a scaling method. The static random access memory cell scaling the slowing with the only 5% of area reduction, observed 5 nm of 3 nm processors and nanometer, challenging the achieving higher density destinations and traditional scaling methods. So the features of SRAM enhancement and scalability design and technology optimization of overcoming the current scaling limitations and meet the demands of advanced computing. So 3D lamp dynamic structures and bond AMDs of 3D achieve enabling significant increase in capacity. It allows the ultra large last level latches and 768 MB high performance computing HPC applications. So these are all about the SRAM scaling 3D integration. Now let us go into Compute Express Link CXL memory hierarchy evolution. The CXL burns boundaries between the memory type and accelerates, creates the unified flexibility memory access across CPUs and GPU storages. AI data workloads, it supports emerging AI data intensity workload by allowing dynamic memory pooling and sharing, optimizing resource utilization, performance and boosting. CXL enhances overall system performance, energy efficiency and scalability, addressing the growing demands of modern data centers. So next one is challenges in semiconductor memory random roadmaps. The ceiling limits, scaling limits or physical scaling limits in the power walls of contains programming shrinking of transistor sizes and lead to increased in heat generation and power consumption. Cost wall increasing wafer reaches development of R&D costs propose significant cost wall of making advanced memory production more expensive. So supply chain, maintaining the supply chain reliances admit the transition of global distribution and crucial for consistent production and delivery. Thermal management means the need of cooling, packing and technologies becoming increased thermal output and high density memory devices. So the high density memory devices may or may not be changed because of thermal management must be equal to the supply chain, and cost wall and scaling limits are interlinked with each other. So these are the challenges of semiconductor memory roadmap. And next one, future trends and industrial outlooks. What are the future trends and industrial outlooks? AI driven memory demand, the reshaping of priority investing leading significant R&D, specialized memory solutions, and advanced packing techniques such as 3D tagging and hybrid bonding becoming key, higher performance and integration. The market of fragmentation and emergence of new players, particularly China, fostering increased competition and innovation. The roadmap targets the signal digital and DRAM nodes of 2030 and beyond, pushing the boundaries and performance. The now the conclusion, navigating the memory roadmap of 2030 beyond and beyond. The memory innovation is critical to sustaining semiconductor growth. The integration of 3D architecture and high bandwidth memory HBM, the Compute Express Link, CXL and SHL for future advancement. Industrial collaboration is also a main play a vital role overcoming the challenges and scalability factors, and other scaling and cost walls may controlled by the data of computing will continue the driven and next decades memory evolution may shaping through future outlooks and technology. The technology of high bandwidth memory increases further enhancement of chips and microprocessors and controllers through the scaling and cost walls of AI data driven technique computing that will be furtherly collaborated with the industrial management and which play a vital role in change of future technology through the different sustaining semiconductor growth technology. Also they also shape the future technologies. Thank you.